Hello. This is going to be a basic rundown of the boilerplate that I developed for my game design space document Data Master. So I made a document that accompanies my master project, and the reason why it was made was to help developers who want to develop games that teach data literacy to students. In this video, I'm going to show a basic boilerplate that I made to accompany the document, and the purpose of this boilerplate is the following. It's going to be providing a very basic implementation of some mechanics. This is just to demonstrate and sort of visualize how the game could look, or what an early build of the game could look like, and also to just demonstrate and show mechanics, because sometimes when you explain something through text or through other visualizations, it's useful to also see an example implementation, just so it's easier to understand what the mechanics and concepts look like. Hopefully this can also help inspire some developers who are interested in working with the game design space document Data Master to develop educational games that teach data literacy. And also I want to give a brief, just a very basic boilerplate starting point in case a developer isn't not quite sure where to start but wants to get in on trying to iterate and do this. This can also be useful if you are going to do user testing, user interviews, etc., to have something visual to show as an example of what a game might look like, or to get feedback as to which direction development should be going, what should be included and not, etc. And the project, or the boilerplate, is going to be available open source. So it's going to be free for everyone who wants to check it out, look at it, look at the code, etc. So this is just going to be a brief overview of what it is. So it was developed in Unity. This is a very, very rudimentary implementation. I have a little bit of an environment set up here. It could be prettier. It's just a very basic environment. And here we see there's some factory pipes and stuff, just to indicate somewhere where pollution might come from. We have two key objects here. We have this pollution object and we have this sensor object. So one of the concepts from Data Master is where you have sensors that detect pollution in the environment. So you would have, for instance, a sensor that you could place out into the environment, move it around, etc. in the game, and it would be able to pick up nearby pollution. And as we can see, the pollution, it has a few values that are available. It has a pollution value, which is just how much pollution it is. It also has some types that are not visible here, and it has a radius, which is how wide the pollution is spread. And basically the way the scripts are set up is that if the sensor is within the pollution radius, it is going to be able to detect the pollution value. And right now it just prints it into the command, into the console. The sensor object, it has a sensor radius, and it also collects a list of pollution objects nearby and adds their pollution up. And if we run the game, it's going to jump to the camera and it's going to probably pick up some solution. As we can see, it starts printing 10, which was our, if we go into our pollution, we can see that 10 was our pollution value. So it's a very simple, basic boilerplate setup to have sensors and pollution in an environment. Obviously they wouldn't be represented as just squares and circles. This is just an example. And we're going to take a very brief look at the scripts before we end this video. So let's open the script setup to see how it's set up. There's actually a lot of lot of data types and stuff set up so that everything is available in case a developer wants to move forward and build upon the boilerplate. It's available. So here we see we have the sensor script. It's a basic mono behavior. We have some very basic data types. We have where it gives you a list of data types, has you a list of pollution sources, etc. And basically how it works is it uses onTrigger enter to detect something with the tag pollution and then adds it to the list of pollution sources. And then it calls generate data and goes through the list and gets there. It calls get pollution on each pollution source. And there's a collection of various scripts here that help in this process, implemented with object-oriented programming. If you want a more detailed look, you can look at the actual scripts online. We're going to look at them very briefly. We have a pollution source that is just a pollution value. It has a radius. It sets the tag through the script, so you don't have to worry about it. And we have a few getters and setters here. We have this reading object that has a data point and a time. Then we have the actual data point, which has a data type and a value. We have a data store that stores the actual list of readings. We have a display that is not fully implemented, but that will be able to ideally display the data on screen. We have data type, which is just an enum that has different kinds of types. I went in the example with the two kinds of pollution particles, PM10 and PM2.5, or PM25 as it entered here. Let's see, is there anything else? We have a data collector as well, which has a list of sensors, and it also has this data store, which we just looked at, and it is able to generate readings by going through the readings for each sensor and adds the reading for each sensor, and then returns them. And it also can store data by calling the store data function, which calls the data store's store readings function on the readings we collected in the generate readings function. So this is the very basic flow of information that is set up. It's supposed to be set up robustly, could definitely be implemented in many different ways. This is just an example. And right now it does a very simple function, which is just to read the value and print it into console. But this boilerplate is meant to be an example of what the data structure might look like. We have some environments, we have some just some very basic functionality that someone might use to explore the mechanics of sensors and a collection. So I'm going to give some examples of how this could be useful. For instance, you could have a game where you have to defeat all the pollution coming from an area, so you have to place out sensors to detect them, and then you have to place out some sort of anti-pollution measure. Or maybe your job is just to collect data. The game might be called something like data collector, and all you're doing is placing out sensors and monitoring different effects. Obviously, this is marketed as pollution in this example, but it could be anything. It could be just an air quality measure. It could be a water temperature measure. It could be anything. This is just a source to send out data to a sensor. So it could be any kind of data. This is just an example of a pollution, but it could be anything if you want to set up a different kind of sensor. The point of the game design space document data master is to show help developers to develop games that teach data literacy to students. So help them understand data in any way. It doesn't have to be about pollution. That's my example. You could also imagine more of like a tower defense structure where you have resources, you place out sensors, maybe like in a top-down perspective. You place out sensors in different locations, and then they collect the pollution, and if too much undetected pollution stacks up, you lose the game. It could be more of a political slant where you're like just detecting problems and then petitioning politicians. One thing we looked at with teachers was we discussed using visualization. So you would have various sensors to collect data and then use different kinds of visualization models to and choosing the correct visualization or the most appropriate visualization. Maybe it gives more points, or maybe it is more helpful to persuade politicians, or maybe it gives some sort of other benefit. So the game is one about using sensors and two about visualizing data. You could imagine more of a sandbox kind of game where you have an environment. Let's say you have some roads around, you have some trees, some lakes, etc., and you're just placing sensors and doing different measurements. Maybe you can adjust the traffic or look at the traffic at different days. So it's more of like an explorative space rather than a game with a clear goal. There's many different ways of doing this. These are some examples, and this basic boilerplate is there just to help developers understand the document and also help them by giving them some ideas. So that's it for the explanation of this boilerplate. It's available online, and good luck in your development. Let's see. Bye.